Okay, good afternoon, good morning, students. Am I audible? Okay. So today we are going to start with Unit 5 of HPC. We have completed Unit 4 of HPC in the last lecture. So we start discussion of the Unit 5. It is based on different parallel algorithms. How different parallel algorithms are written for parallel platform. That is what this particular unit mainly contains. Unit 5. Okay. So yes, give me a couple of minutes. I'll just share my screen. Is the shared screen visible, students? Okay. So these are some of the topics which we'll be covering in the first half of the fifth unit. This is not the complete fifth unit. Okay, this is just the first half of the fifth unit. So we'll have issues in sorting of on parallel algorithms. This is not there, sorting networks. Then bubble sort and its variants. Then we have quick sort and bucket and sample sort. Okay, these are some of the concepts that we will be discussing in the first half of the fifth unit. Okay. Now speaking about sorting overview is the first topic in the fifth unit. One of the most commonly used and well studied kernels. So this is one of the most used and well studied part of the parallel programs. This module is the one sorting is very commonly required in many applications. So this is the one of the most common and well most used part of the parallel algorithms, okay, or parallel programs. Sorting can be comparison based or non-comparison based. So sorting can be comparison based or non-comparison based. Okay. The fundamental operation of comparison based sorting is compare exchange. So one of the most fundamental operation of comparison based sorting is compare exchange. Compare exchange means what? There will be two processors, let's say, each containing one element. They will exchange the elements with each other, and once they exchange, so every processor will have two elements with it, okay, and the minimum part will be kept by the left processor, and the larger number will be kept by the maximum value will be kept by the right processor. So in this way compare and exchange can be done in parallel platform. We'll go into more details of it as we discuss this unit, okay. So they compare the numbers and they exchange the values if they are less or greater than the expected value, okay. The lower bound of any comparison based sort of n numbers is theta of n log n. So the lower bound of any comparison based sort of n numbers is theta of n log n. We focus here on comparison based sorting algorithms. So in this unit specifically we are going to focus on comparison based sorting algorithms. Okay. Now other some sorting basics. What is the what is a parallel sorted sequence? Where are the input and output lists stored? So how are parallel sorted sequence kept? And where are the list stores of input and output in the parallel platform? Okay. So we'll discuss that how it works on a parallel platform. So we assume that the input and output lists are distributed. So what do we assume? That input and output lists are distributed in the parallel platform. The sorted list is partitioned with the property that each partitioned list is sorted and each element in processor Pi's list is less than the Pj's list if I is less than j. That means what? There are lists with every processor. So first processor will have some list, second processor, third processor, fourth processor, and so on. Okay. So the partition list, each processor will have a sorted list with itself. The whole list is not sorted, but the list with each processor is sorted. That is what is taken for granted. Okay, and list with, let's say, processor 1 will be less than the list with processor 2. So all numbers in the list 1 will be less once the sorted is done. Okay, so that way the list will be, output will be uh, sorted once the partitioning and the sorting is done. Okay, so list with processor 1 will be less than the list with processor 2. This will be the output after the sorting is done. Okay, so for pi less than pj, that means what, 1 is less than 2. So pi is, let's say, p1 and p2. So p1 list will be less than the p2 list. Similarly, p2 list will be less than the p3 list. That way the sorting will be, the output will be there in the parallel platform. Okay. Now in sorting, how does the compare exchange operation work? So suppose there are two processors, pi and pj. Okay, so both are basically exchanging the values they have with itself, with the other processor. So ai is given to pj, aj is given to pi. So pi will have ai aj and pj will also have ai aj. Then pi, what it will do is that processor 1, let's say, will do minimum of ai aj and pj will have maximum of ai aj. So whatever is the minimum of ai aj, the processor, less indexed processor will have that value, and the larger indexed processor will have the max value. So this is the parallel compare exchange operation. Okay, a parallel compare exchange operation, processors pi and pj send their elements to each other. Process pi gives minimum of ai aj and pj gives maximum of ai aj. This is how compare exchange operation happens on parallel processors. So consecutive processors will exchange the numbers with each other. Minimum will be kept by the less indexed processor and the maximum number will be kept by the greater indexed processor, like p1 p2. So p1 is less indexed, p2 is greater indexed. That way compare and exchange will happen on a parallel processor. Getting this, students? How compare exchange operation will happen on parallel platform. We'll go into specifics, more details later, but this is how consecutive processors will exchange the values if they are not sorted. That means consecutive processor values will get sorted by compare and exchange. Okay, so each consecutive processor will do the compare and exchange, which in turn will result what, with all this compare and exchange operations, the whole list will get sorted. Okay, so this is how compare and exchange works on parallel platform. Getting this, students? Yes, Nehal, Ketki, Madhuri, Rutuja, others also, Ajinkya, Isha, Meenal, Neeraj. Getting how compare exchange works on parallel platform? Now some other sorting basics. What is parallel counterpart to a sequential compare? No, okay, sorting basics are not there for you. Okay, so remember that sorting networks and sorting basics are not there in the syllabus, but I've kept it in the PPTs for content beyond syllabus. If anybody wants to go into content beyond syllabus, you can go into sorting networks. Okay, Lot of PPTs are there for sorting networks. Okay. Now the next part in the syllabus is bubble sort and its variants. Second topic in unit 5 is bubble sort and its variants. The sequential bubble sort algorithm compares and exchanges adjacent elements in the sequence to be sorted. So sequential bubble sort, what it does is that it compares and exchanges adjacent elements in the sequence to be sorted. See, remember, again I am repeating, there are a lot of extra points also in the PPTs. I have not removed them intentionally so that anybody wants to go deeper into the subject content beyond syllabus. I have not removed it from the PPTs. But those who want to specifically study exam point of view, follow the syllabus topics in the PPT. Then you can be prepared for exam point of view. But if you want extra knowledge, you can go into the content beyond syllabus. Not all units have that. Some units I have kept some content beyond syllabus PPTs also in the shared presentations. Okay, so take care of that. If you are not interested to go content beyond syllabus, you can specifically follow the syllabus, and accordingly those topics can be studied. Okay. Okay. So sequential bubble sort algorithm compares and exchanges adjacent elements in the sequence to be sorted. Okay, adjacent elements are compared and they are sorted. Okay, so for bubble sort procedure, what happens is that there are two nested for loops. Okay, two nested for loops are there, and compare and exchange happens between adjacent elements. So for I equal to n minus 1 down to 2 to 1 and j equal to 1 to I, compare exchange a of j and a of j plus 1. Okay, adjacent elements are compared and they are sorted. Okay, so this is how sequential bubble sort works. Okay, the complexity of bubble sort is O of n square or theta of n square. Bubble sort is difficult to parallelize since the algorithm has no concurrency. But what happens is that the algorithm is not having concurrency, so it is difficult to sort that algorithm. Okay, so simple variant though uncovers the concurrency. So by modifying the bubble sort little bit, you can have concurrency in the bubble sort algorithm, and then it can be parallelly more comfortably executed, and it will get benefit from parallel platforms when we have concurrency in the algorithm. Concurrency means what? Parts of the algorithm can be parallelly executed. So when you have parallel available parts, that can be parallelly executed on the parallel platform. Okay, so for that they have this odd even transposition. So what is done is that for a number of elements n, for I equal to 1 to n, if I is odd, then j equal to 0 to n by 2 minus 1, compare exchange a of 2j plus 1 comma 2a of 2j plus 2. So these two elements are sorted when basically you have I is odd, and when I is even, for j equal to 1 to n by 2 minus 1, compare exchange a of 2j comma a of 2j plus 1. So the list is divided into two parts. When I is odd, specific numbers are exchanged, and when I is even, other specific numbers are exchanged. So it is concurrently divided into two parts. So concurrency has been generated here. You can have a look at that. So you are dividing the list into odd list and even list. This approach is called as odd even transposition. So bubble sort, which didn't have concurrency, parallelism in it, is modified to odd even transposition. So instead of directly comparing consecutive numbers, odd index numbers are compared, and even index, when I is even index, that time it is compared and basically exchanged. Okay, so see here they are given an example. Okay, it is not properly visible in this slide. I'll just take another, take it from the PDF. Just a minute. Is it now properly visible, students? Only this diagram I'll take from the PDF. Is the PDF visible, students? Yes, students, is the PDF visible? Okay, yes. So look at here. When I is odd, okay, that is I is 1. These two numbers, this index 1, 2, 3, 4, 5, 6, 7, 8, these numbers are compared and exchanged. Whereas when I is even, 2, 3, 4, 5, 6, 7, these index numbers are exchanged. Again in the next pass, when I is odd, 1, 3, 1, 2, 3, 4, so on. So that means when I is odd, the first number is odd indexed, and when I is even, the first number is even indexed. So list is divided into two parts, odd and even parts. So when I is odd indexed numbers are, starting numbers are exchanged, and when I is even, starting even index numbers are exchanged. So this is where you work for odd even transposition, okay, in bubble sort. So sorting n equal to 8 elements using the odd even transposition sort algorithm, during each phase n equal to 8 elements are compared. So 8 elements get compared in each phase, odd phase and even phase. Getting this, students? How odd you see, I'm telling you, there are a lot of innovative changes going to be made in conventional algorithms for parallel programming. To get the benefit of parallel programming, lot of small changes will be done in your conventional algorithms like bubble sort, quick sort, merge sort. Lot of innovative changes are made by the parallel programming people, and that we are going to use in the parallel platform. We cannot directly use the existing algorithm as it is. We are going to little bit modify them, and then we are going to use it in the parallel programming. Okay, so clear with odd even transposition, students? Just try to understand the concept. So there is odd phase and even phase. In odd phase, odd index numbers, starting numbers are exchanged, and in even phase, even index numbers, starting numbers are exchanged. So you look at the diagram. Here first number is odd indexed. Second also, this is 3, that is odd indexed. This is 5, that is odd indexed. So odd index, this is 7, that is odd index I am talking about, not the number, index of the number. And this is odd in the phase 1 is odd, phase 2 is even, phase 3 is again odd, phase 4 is even. This way it is continuously done, and then you are getting sorted. So see here 3 and 2 are compared. So 2 gets, 2 is less than 3, so 2 will go to the left, 3 will go to the right. Okay, 3 and 2 are compared, 2 will go to left, 3 will go to right. 3 and 8 are compared, 3 is less than 8, so 3 and 8 will remain as it is. 5 and 6 are compared, 5 is less than 6, so 5 and 6 will remain as it is. 4 and 1 are compared, 1 is less than 4, so 1 will go to the left, 4 will go to the right. So this way, same way, compare and exchange operations will be done between the two consecutive numbers selected as per the odd or even phase. Okay, getting this, students? Yes, students. Isha, Snehal, Meenal, Ajinkya, others, Neeraj, Amruta, Rutuja, others also. Yes, getting this, how odd even transposition works? Okay. Now speaking about the odd even transposition, after n phases of odd even exchanges, the sequence is sorted. So after n phases of the exchanges, the sequence becomes sorted. So if you look at this, in the last phase, the sequence is sorted. Okay. Each phase of the algorithm, either odd or even, requires theta n comparison. So you require theta n comparisons for the sorting. Serial complexity is theta of n square. Okay. So parallel odd even transposition, consider the one item per processor case. So what you can do is that each element of the list can be allocated to one processor. There are n iterations. In each iteration, each processor does one compare exchange. So in each iteration, each processor does one compare exchange. So if there are n numbers, there will be n processors in the parallel platform. The parallel runtime of the formulation is theta of n. So the parallel runtime is theta of n. This is cost optimal with respect to base serial algorithm, but not the optimal one. So if you take the base serial algorithm, that is bubble sort, with the serial bubble sort, the parallel bubble sort is cost optimal using odd even transposition. Okay, but not with the optimal one. So if you compare it with quick sort, it is not cost optimal. But if you compare it with the base serial algorithm, it is cost optimal. Okay. This is the odd even transposition. So odd even parallel with for n numbers, id equal to processes label. So I processes are divided from 1 to n. There are n number of processor. Processor 1, 2, 3, 4 and so on. That is the id. So for I equal to 1 to n, if I is odd and if id is odd, compare exchange minimum id plus 1. And if else, compare exchange max of id minus 1. So first processor will do the min part, next processor will do the max part with it. Similarly, if I is even and id is even, compare exchange minimum of id plus 1 and maximum of id minus 1. So left processor will keep the minimum value and the right processor will keep the maximum value. So it will be done for odd indexed processors and even indexed processors. So this is how it will work on parallel platform. Each processor will handle one number. So there are n numbers, there will be n processors. So processor 1, 2 to n. And each processor and consecutive processors will do compare and exchange operation. Minimum will be with the left processor, maximum will be with the right processor. Getting a concept, students, how it will work on parallel processors. Each number with one processor, just whatever we saw for sequential algorithm, same thing will be done for parallel algorithm. So whatever these numbers are there, instead of numbers there will be processors with the numbers, and consecutive processors will do the compare exchange operation. So it will take theta of n will be the parallel runtime. So odd index will do the odd phase compare exchange, even index will do the even indexed compare exchange. So same way as it worked for serial, only difference is here it will be processors which will handle each number. Okay. Getting, students, how it will work on parallel platform. They have not given a diagram for that because it is immediately understandable. Each number one processor. They have not given a separate diagram for parallel execution of odd even transposition version of the bubble sort. Getting, students? Yes, Ajinkya, Isha, Snehal, Rutuja, others. How it will work on parallel. We'll go into details in the next lecture of the complexity of it. Okay? Because you have an expert talk now, I think on AI. So I'll not leave you late today. I'll leave you a bit early today. Okay? At 11, I think you have the expert talk. Yes, clear with the concept? Isha, Neeraj, Snehal, others, Meenal, Ajinkya, Rutuja. Okay? Okay. Give me a couple of minutes. I'll just take your attendance.